Hello and welcome to another episode of Modern Infrastructure Wednesday. I'm your host Lee Zen. Today we're going to be going over serverless image recognition. So using serverless functions to do some image recognition and really trying to actually use the full depth of machine learning here to do so. So what do we cover? We're going to be covering creating a Lambda function, so fairly basic stuff, but then really integrating it with a PyTorch Lambda layer. So using PyTorch as a layer to load in that whole library and then get the full benefits of using a fully featured framework like PyTorch. And then we'll integrate the function with an API so that we can go ahead and actually start calling it, invoking it against things we want to do image recognition against. So let's get started. I already have a program open actually, and there's a couple things in here kind of worth showing you. I kind of already wrote all this up because there's a decent amount of code that I didn't want to necessarily live code this. So I'll just walk through the code and then we can kind of understand how everything fits together, and then I'll show you a quick demo of how it all works. So yeah, the first thing we do is we define a bucket for putting our model. So this is the image recognition model we're going to be using. In this particular case, I'm using a fairly simple model. It's a ResNet 50 model for those familiar with machine learning, and it's a pre-trained model from Torch Vision, and so the one thing I did do is I converted it since the layer I'm using is in PyTorch 1.1, and the model itself is actually coming from an older version, the pre-trained model. So there's a simply convert utility here that I wrote to do that conversion. So we convert that, we package it up with some labels, and then we ship it as a archive. And this file is shipped as a bucket object and defined in our infrastructure. So our infrastructure has defined both a bucket and a bucket object. You'll notice today I'm using Python, and you'll also notice one of the cool things about the Python support, if you've used Pulumi's Python support before, is that we actually have improved typing now with some of the changes we made recently. So you get better autocompletion in your IDE and better typing actually across the board with the properties. So just something I thought I would show anyway, since we're using Python. It's a natural language to use for machine learning. So okay, so we have the bucket, we have the model object, so we have that uploaded, and that's going to get used by our Lambda function. And so our Lambda needs to be able to do a few things. Obviously, we give it a service role for Lambda, and then we define this role, and we set it up so that you can use logs and post to CloudWatch, and then we also allow it to read from that bucket. So we actually give it all the permissions for the bucket, since there's not a whole lot to do in that bucket. So you can see here I take that bucket ARN and then I do an apply so that it can include this little asterisk here to indicate all things in the bucket, all keys, and then we allow all things. So this role is attached to this Lambda function, and this function is then basically an archive of this app, and I'll show you the app in a second. And then we define it with some parameters like this, and then we give it a layer. So this layer includes a pre-published PyTorch v1.1 layer that someone out there kindly has used, and actually I reference that repo in the app, so we'll get to that in a sec. And then we pass this function a couple of environment variables. We give it the bucket and the key where the model lives. And that's pretty much it. You'll notice that I also give it a longer timeout and memory size because this actually takes quite a bit to run in terms of loading the model initially. So in fact, sometimes you may even have on the cold start a timeout in terms of the initial timeout to load the model, but subsequent runs, once that model is loaded and the function is warm, are fairly fast. And you'll actually also note, since it's Lambda, we're actually running the model completely on CPU and not relying on any GPUs, but we still have fairly good performance for this small model. The model itself it's roughly 100 megabytes in terms of all the weight data. So we have the function, and then now the last thing we want to do is connect it to an API. Here you can see I have a simple Swagger spec that basically defines an API with a proxy path, and then this sets up the integration for me for a post method, and then after that, we basically have this API with the Lambda ARN. So the whole thing here basically sets it up so that when we call any path against this API, it will invoke with a post request. it'll invoke that Lambda. And then we finally set up a deployment in an API stage, and we give it permission. We give we give that specific API permission to execute our Lambda, and that's it. And at the very end, we export the invoke URL so that we can actually know what URL to call off of the REST API. So that's kind of the whole structure of the infrastructure we have. Like I mentioned, a bucket and a bucket object that represent where we post the model. We have this function along with a role that has the right permissions, and the function we'll get into in a sec. And then we have that function integrated with an API gateway. So you can see I have in my structure, I have this app here, and that's what's referenced by this archive over here. And in this archive, we have this app.py, and that's actually the function itself. This is pretty much copied from an existing example. One change I made is that I load the model a little bit differently to make sure it loads correctly. And then after that, everything else is more or less the same. You can see we basically, the way this function works is we have a request body. The request body has a URL for us to classify the image, and then it uses a pillow to load the image and transform it into the correct format. And then we basically do prediction using our pre-trained model against it, and then finally return the response based on that. So that's all the code actually. And I already ran Pulumi up earlier. So all this stuff's already been deployed to the cloud. And so now the only thing left to do is kind of show you an example of running this. So the function right now is actually cold. So this is a cold run of the function, but you can see the way we'll invoke it is we'll do a curl, and then we'll give it the body that we expect, which is a URL. It's a JSON document with a URL, and then the URL of the image we want to classify. In this case, if you want to take a look at this image, that finally, as I'm recording this, that site is down. So let's not do this. Let's do this instead. This is another one I had prepared. So if we look at this image, let's load this up. You can see it's this dog. And so yeah, let's run this. And you can see it's sitting here for a little bit, and it's going to take a little bit of while. So now right now the Lambda function is running. It's loading that model from the S3 bucket and loading that into memory effectively. So this, I expect a timeout, so I'm actually going to pause the recording here, and we'll come back in like a minute after it times out. Okay, so yeah, you can see this timed out. As I mentioned, typically the first run, it's not going to always work because of how long it takes to load the model. You can obviously, if you want, increase the timeout, and so it's actually very easy to do. We can actually just go to the function and change this timeout to be, something longer. Like you can imagine, give it 5 minutes instead of the single minute. And we can just, run Pulumi up to change that, and you can see, give us a diff of that function. But I'm actually not going to do that. I'm really just going to wait for it to load the model. So let's try running the command again. And this time you can see, since the model was already loaded, it completed very quickly. And you can see now we've predicted that this is a Maltese dog or a terrier with high confidence. And again, I mentioned earlier that the model is pre-trained against ImageNet, so the labels are against the 1,000 various classes of ImageNet. So you can throw pretty much any image at this thing, and it does a pretty good job. This is one of those models that's done fairly well over the years. But yeah, that's the whole example. So really, in a few simple lines of code, we were able to set up our bucket object, connect that to a role with a function, and then have that function call, and actually really want to emphasize we didn't really have to package up any dependencies in our code. You can see that the app was super simple. It's just this one file. There's no other things that are getting uploaded as part of this because the layer handles all that dependency management for us. And then once we use that layer, we are able to load the model, use PyTorch to do our inference, and then get back a result. And so, yeah, I hope you enjoyed today's episode. Please make sure you like and subscribe the video, like the video, subscribe to the channel, and we'll see you next week on Modern Infrastructure Wednesday.